Okay. We want to start a new unit quickly, right? The first one, hopefully you understood, and the examples that we were doing last week made sense. I did say that I'll give you something like a tutorial for you to just get used to the calculations and how you apply the performance formula that we introduced. Okay, and also your project is still in the baking. It should come out soon. Okay, so be ready. Just be ready. And like we said, the project is just aimed to force you to, understand the stuff as we do them, right? Yes, it's not really anything which is meant to break your neck. So take it positively. So we did an introduction. This is still an introduction, okay? And you see that the way we do the intro is that we cover everything, okay? We cover everything that we are going to cover in the course, but we just do, overviews so that at least you can begin to chew the concepts in their simple form. And then when we revisit them, we add more layers and you are not lost in the process, okay? So we just want to quickly give an overview, more so like a complete overview of a computing system, all right? We largely dwelt on the processor in our earlier sessions, but we want to speak about the processor, yes, the data part, yes, I/O, and the software as well, okay? The application software, all the components that are really, are at play, in a computing system. So these are the objectives. Provide a system overview, right? So a system overview meaning a computer is a system. So what makes a system is the components and how they interoperate. Okay, so we pick at the components, we look at their function and structure at high level. Okay, yes, and then we go into the software, as I just said, and we will see that software can be classified into two categories, all right? Application software, which is the applications, which are consumed by the users, okay? Yes, the applications, and then the system software, which is there to support the application software. So we'll touch a bit on that. And then, yes, the functions, all right? So, this is another boring stuff, repetition, okay? But we do repetition, okay? And we like simple things because we are not here to memorize, okay? Yeah, we are here to learn and understand, so that by understanding you can come up with something better, okay? Or apply the knowledge to, create real impact, okay? As a computer scientist, as a computer engineer, as an electronic engineer, as a data scientist, okay? As a business analyst, okay? You bring real impact. So these are the components of a computer system, okay? Yes, it's the hardware, which is where our interest, especially in this course, is, okay? Then it's the system software, okay? That layer between the hardware and the application software, right? Yes. So, clearly the system software is a bridge, okay, for application software to, utilize the hardware, okay? Yes. So this is largely more of a revision, so we'll pass through it quickly. The system software is designed to provide platform for other computer software. Okay, platform, it's like an environment. Okay, to run WhatsApp, you need an environment for WhatsApp to run on, because WhatsApp cannot directly run on top of your phone, right? Hardware. Okay, you need an environment. Like what your operating system, which runs on your phone, Android. Okay, so then Android becomes a system software. Okay, because it's software which is designed to provide a platform environment for other applications to work. So it's a gateway, okay, an interface, okay, interface between the computer system hardware and your application software. So many types of them. Okay, OS, compilers, drivers, you get it. Yeah? So of course you will have an opportunity to study more about system software, particularly your operating systems in OS 1 and 2, okay, how they are architected, the components, the kernel, right? But that's not the scope of this course. But it's good to do architecture with that understanding in mind that, oh, okay, I'm at the hardware layer, there's the system software layer, there are applications here. What I'm doing at the hardware layer, okay, affects, what happens at the upper layers, right? So those are the basic functions of operating systems, being all the layers between applications and hardware. You see that, it includes CPU management, right? That's your OS, to coordinate how multiple applications share a single processor, or how they share the multiple processors that are available on your hardware. Okay. Memory management. Okay. Yes. How do we get multiple programs running on limited memory? Okay. So it's the function of the OS to supervise that. Okay. If it gets full, some are evicted. Okay. To give room for those that have more priority. So device drivers. So it is responsible for providing that system level code, okay, that will interface your device, your mouse, your keyboard, your whatever, okay, with the processor, right? And I/O management, yes, all the I/O functions that we require to do, right? So the compiler also is an example of system software. We did discuss the role of the compiler in in performance, isn't it? Yes, and performance, because the compiler takes code written in high level form, isn't it? And then it translates that into machine code, right? Yes. So it is a system software. Why? Because it makes applications able to utilize the hardware. And the more intelligent or the more optimized the compiler is, the more it's able to eject, or actually output optimized machine code, and therefore the application utilizes the hardware better, right? We have a number of compilers, the cross compilers, meaning a compiler which is able to target multiple architectures, right? And then you have your bootstrap, your decompiler. It means from machine code back to, you know, high level code, okay? Source to source, which could be Python to Java, okay? You know, it compiles source to source, or hardware synthesis, right? That's the compilers that I think we were referring to the other week when we said the way hardware is generated is that you write code, right? You write code, you know, which describes your chip, isn't it? And then the kind of compiler which translates that code into a net list, which is used to fabricate an IC, okay? That's a synthesis compiler. And of course, we are not very interested in that in this course. It's especially the scope of those who do electronic engineering, right? Where you actually go into chip design, okay? So you will come across synthesis compilers. So a compiler which is able to take code written in Verilog, for example, or code written in VHDL, and then it generates, okay, a netlist, you know, which is used to create the chip, okay, showing which gates, you know, do what to implement the function that you want your circuit to perform. Application software, this is where we mostly are and we enjoy, you know. Yes, word processing, yeah, browsing, I mean, all the jazz. You get it? But one important philosophy that we want to maybe bring to your attention is that of open source, you know, software, you know, either open source system software or open source what? Application software, right? What do you think? They're there, it's fine, okay? But don't read, okay? Don't read. What are the benefits of going open source? For example, for an institution, I mean, let's say you are a university, all right, and then you want to have a, you know, like a student management system, okay, an application, right? Or you want to have an email application for the university, right? Yes, or you are government, right? You want to have electronic medical records system, okay, which can be used in clinics and hospitals to manage patient records and to digitize health processes, okay? What do you think are the benefits of using either, yeah, like of using an open source, you know, software, which means the source is open, okay? It's free, okay? And even the source code is in the public domain, right? It is something that can be taken by anyone. They see how it works, you know, internally, and they can even use it, all right? So I'm saying, what do you think are the benefits of going open source as opposed to going commercial, which means you pay? What do you think? Okay. The other one is free, you know, meaning savings. That's an obvious benefit. Savings, you save money. Open source, yes. Open source saves time. Open source saves time. Okay. Real household.
In such a way that when you go commercial, the code will have to be developed from the beginning. and all the processes will have to be undergone. While in open source, we just take the code and edit it.
Okay, he's saying with the open source, you find the code already there, the application is there. You simply take it and you deploy it. Whereas for commercial, it has to be developed from scratch.
Yes.
Okay, it depends. Okay, it depends both ways. Of course, it's true. There are times where what you need for your context is unique, right? So it has to be built from scratch. So perfectly more time, all right? There are times where what you need is already there, okay? You know, there are software vendors who have built such application software already. All they need is your money, okay? And they give you the application, all right? Or at times, there are times where the open source one is there, okay? But because it's open source, meaning it's built for everyone, it doesn't answer your business processes, okay? You still need to okay, yes. So it goes both ways. That's good, that's fine. Again, yes.
So I think going for open source, opening up for more collaborations, in a way that source code, like say, it's free at the end of anyone can access it. Like I also think it allows it allows organizations to do modifications to the social context required according to the specific need.
Perfect, right? So of course, the fact that your code is open source, like he's saying, there's room for more innovation. Okay, yes, I mean, why? And then you have thousands developers working on the same source code. Okay, some are academics, some, I mean, it's everyone. Okay, contributing to this source code. I mean, like your I mean, like you compare Windows with Ubuntu, for example. Okay, this is commercial. Of course, it's nice, and the goal is to make money. This one is free, okay, and has a large base of contributors, okay, that builds the kernel, they fix bugs, okay. So there's more room for innovation, and also for support, okay, when things fail, and also it's easy to adapt the solution, to your needs, okay. Because of course you have vendors that have pre-built applications, and they won't always fit what you want, okay, and for them to be customized to your need, that's cost, right? Yes, but with open source, of course, it's cost again to customize, okay? Because if you are a university or a government department, it means within the department, there should be an ICT unit, okay? There should be an ICT team that's able to take an open source, source code, work on it, okay? Change the interfaces, right? Yes, that's more money, okay? Yes, because it means you employ people now and you pay them, right, to maintain the software. Yes.
So I have a follow-up question to the previous one.
Yes. Which
So,
one on cost?
I think generally we're talking about how can you say the game gauge?
Oh no. Saves
Yeah,
time.
well, yeah, it's essentially we're talking about it saving time, so.
Yes.
But I think he basically alluded to like the. Compliance.
Compliance, okay.
My question is
Uh-huh.
on compliance. So,
Okay.
now, how does it relate when we improve on the already existing code?
Yes.
Are there any compliance issues that need to be considered, coupled, and just continue from there without consideration of compliance requirements?
Okay. Yes. Of course. That's a risk. Okay. That you have with open source. Okay. Because I mean there are standard ways, of doing things. Okay. And when you buy pre-built software, okay, then you rely on the expertise of the vendors that, I mean, they they build good compliant software, okay? Depending also on the scenarios where the software is going to be used. I mean, if it's in the finance sector, okay, there are compliance issues that, I mean, there are standards that the software has to adhere to, all right? So if you take an open source software and then you want to apply it in the finance sector, all right? And then you don't have a sound technical team, right? Then you can have compliance issues. I mean, why? Because the software is there, is free, anyone can take it, enhance it anyhow, and use it, right? Yes. So if the quality of the team that you have is not sound, meaning the enhancements done won't be compliant, it means there would be issues of security with your software as well. So perfect point. One other main benefit, okay, hence why you see in Lesotho, for example, or most of this underdeveloped or developing countries, okay, why we go open source. It's an issue of sustainability, right? It's very key. Sustainability, right? Meaning the ability for us to sustain the solution, right? So that if the government changes, okay, we still want this application to work in the hospitals, right? So if it's tied to money, such that we have to pay licenses every year, right? And depending on who's on the table and who has the cake, all right? At times, there are those who will misuse and mismanage the funds, all right? Or there could be delays in the processes to process payments, okay? You find that we have 218 clinics in the country that are using software that requires a license, okay? And then there's a delay in paying a license, okay? Then for 2 months, okay, the business operations in clinics are affected. That's the issue, right? But when the software is free, we don't have to pay licenses, all right? Yes, we don't have to pay licenses, but we have to now invest in human capital, right? Capacity of, I mean, for maintenance and for support. And that's another benefit, okay? Because by making it open source, you are creating jobs, basically, right? Okay, yes. I mean, because instead of relying at a firm in Santon or in Europe or Asia, okay, to customize the software for you, okay, it makes more sense to now build technical capacity locally, all right, of developers that know how to customize the software, how to support it, how to enhance it, all right, and be contributors to the bigger open source community. That's why you see, I mean, after you graduate, for sure, you are likely to land careers in data science, okay, especially in the health sector, right? Because that's one of the active, you know, areas locally, and a lot of applications that are used, okay, you know, basically 90% of the applications which are used, okay, from the application which is used to digitize Dukan, okay, it's open source, okay. The application which is used to manage the pharmacy, right, it's open source, okay. The application which is used to build a national data warehouse, okay, you know, for health, where all health data is collected and analyzed, it's open source, right? And the application that we use as the university to manage learning tutor, it's what? Open source, right? Yes. The university does not need to pay a thing for tutor, you know, in terms of licenses, okay? But of course, it needs to now invest in a server, okay, and a technical team at the university, okay, to maintain what? The tutor to support it, which is good, right? Yes. So remember open source, okay? Yes. Remember open source, love it, live it, preach it, okay? Yes. Because it's good. Because it's good. Yes.
In contrast to the true open source
Yes.
how would you say concerning the friendliness in managing security and vulnerabilities in contrast?
Good question. You know, it's actually a build up to what she said, you know, which was speaking to issues of compliance, but you're going straight to issues of security, right? It depends, okay? But one, because an open source solution is built by a big community, oftentimes, okay? It means it's something that is tested, okay? And there are many attempts to break it, all right? And then, of course, many attempts to do what also? To close the holes, right? Yes. So it can be more secure than the commercial one because of that. But again, during the customizations now, all right, you know, you can introduce enhancements to something which is open source, extra functions, extra modules, okay? But depending on your capacity, right, then you can introduce vulnerabilities to something which was, you know, soundly secure prior. So it depends, but largely, security is not a main issue with open source, okay? Hence why Linux or Ubuntu is more secure than Windows, right? Right, yes. And you can, yeah, fine. You get me, all right? You can do, you can do more dirty work on Windows using Linux. All right?
Yes.
All right. Are we together? All right, so that's your that's a summary of the open source stack. Okay. covering system software and as well as application software. So there's open source for everything, okay? For everything, like really. There's open source for everything. And the nice thing about open source also is that it has the business element to it, all right? If you see that there is a need for a certain application in a certain domain or sector, okay, you really have to build that application from scratch yourself, okay? You really have to do that, okay? Of course, there's room for that, but you have to recognize that depending on the scale of the application, okay, building it alone from scratch, you're going to take more time to build something which is sound and mature, right? But if you want to do business, right, you can look for something open source, right, which has already a sound foundation. Then you bring in your good expertise to enhance it. Then you sell that enhanced open source, right? Yes, I mean there are many open source applications that have free version, okay, and premium version, okay. It's open source at the base, but the vendor has added some modules to the open source, okay, and those modules are closed, okay. They're hidden, okay. Then they sell them to you on top of the open source, all right? Yes. So the idea is whether it's yeah, man, it's in education, it's in governance, it's in finance, it's in banking, it's in smart farming. There's open source AI. I mean, all right, there's a lot of free tools, you know. The main contributions now is to add something, okay, you know, to customize that to your context. Yes. So we have open source operating system. This one, mistake, doesn't belong here, this one, okay? Yes. You have open source security frameworks, open source application runtime frameworks, okay? Open source compilation tools, okay? DB and big data, I mean, there's a lot, okay? There's a lot. Yes, so get that. Let's go into the hardware side of things with that appreciation, okay? Open source, put it here, okay? Write it here, okay? Write it, open source, sing it, okay? Open source, right? Yes, open source, okay? It's the way. All right, so we have introduced the hardware already in our previous unit, right? And I don't know if we did this, but I like to you know, to do parallels between computing and the human mind or brains or conscience, okay? Yes, because I mean there are lots of similarities, okay, and attempts to emulate, okay, and if you do architecture correctly, okay, right, okay, if you do it correctly, right, and you learn correctly, you should come out of the course a better person, okay. That's the better person. Not simply a better, okay, a good computer scientist, okay, okay, a better person, okay, a better human being, right? A better human being, right? And equipped with, maybe simple, um, simple tools that can enhance your becoming, okay? You're becoming a good version of yourself, all right? Yeah, okay. From 1.0, 1.2, okay, 2.0, okay, good version of yourself, okay? Always upgrading. Yeah, yeah, right? Yes, and the best upgrades you can do are here, okay? All right, that's it. All right. And the best thing you can do for yourself, okay, is to understand how this thing works. Okay. I'm done, guys. Okay. I'm done. Done. You don't get it. All right. So we of course right? It has the parts which are not moving, right? But they act as pathways for us to put input, all right? And the input actually travels through the machine, and then there are the moving parts, internally that grind the inputs, to generate the output, all right? So you still have the data part there, okay? You have the processor, and then you have the control unit, all right? Kunjalo? Unless I was really low, I don't know. Yes. What's up, and you think from it's a shop? All right, so that's the summary of the hardware components, the input devices, the output devices, the memory, the processor, okay? And then within the processor, we have the control unit, we have the arithmetic and logic unit, we have the CPU registers, right? Yes. So this is more of a revision that the way this whole thing works is ask and take, okay? Ask and take, where your processor is the master and then memory is the slave, okay? Yes. And we were saying, no matter how powerful a data path you have, okay, or the hardware has, okay, that is not sufficient, right? It's not sufficient. What does the magic is the control unit, right? Okay. Physically, you may be born with a very good brain, okay, because of your genes, okay, right? Yeah, genes. Just naturally, your brain has fast processors, okay? Yeah. You have good memory, you have good, you have a good brain physically, right? Right? But without a good control unit, rubbish. Okay. I'm serious, rubbish. All right, rubbish. You are not going anywhere with your high IQ, okay? With your very high IQ, you are not going anywhere. I don't know if you get me, okay? You're not going anywhere. Because life is more, Life is more about EQ than IQ. All right. What's EQ? EQ is emotional intelligence. Okay, quotient. Okay, ability to regulate your emotions, resilience, patience. I mean, that's why you find people who really make it in life. Okay, people who really become the best version of themselves. They are not the A's or the B's. Okay. I hope you are listening. Okay. Not that. Not that. Not that it's wrong to get an A, but okay. All right. But if that's all you focus on, the IQ, all right? Okay. That's where you will end, right? That's where you will end, right? Because people who, yeah, I mean, people who do innovations, who do big businesses, I mean, who, there are people who have everything balanced, okay? Everything balanced. A good brain, but also a good will. Will, meaning the power that governs who you are, okay? You know, the ability to say no, to say yes, to say wait, okay? The ability that, okay? All right. So I need to go home with your good brain. Okay? Let's go home with your good brain. You get it. Okay. So I mean, don't be all, I mean, all proud with your blue sweaters, you know, CS. I'm not saying you are proud. Okay? I'm just saying. Just be humble, okay? Be humble, okay? These other people, okay? These people that you call other, okay? Other. Yes, I'm BSc. Be very humble. Very humble. Rather, grow yourself vertically and horizontally, okay? Yes, grow yourself in all yes, aspects of life, okay? Yes, right? Then your IQ, but I'm just saying statistics show, okay? Yeah, and they don't lie. So you can try to, you know, work against statistics, it's fine, but statistics show, all right? Largely, a high IQ can be a curse, okay? Yes. If you don't hold it nicely, okay? Like a full cup, okay? A full cup, you know, you have to walk slowly with a full cup because it's easy to spill stuff, okay? But I only have, you can run and do all. Don't spill it. You're fine. But when